Welcome to the deep dive. Okay, so today we're digging into some specific source material. It's actually a document with practice questions and explanations for the Hitachi HQT-6712 exam.
Right.
But look, forget the exam part for a moment. Our mission here is really to use this material as a kind of, shortcut.
Hmm.
We want to pull out the key nuggets from these questions to get a handle quickly on some important Hitachi storage concepts, things like Ops Center and GAD systems, Global Active Device.
Yeah, GAD comes up a lot.
The source does give a little context, mentions the exam is web-based, 60 minutes, 35 questions, you need 65% to pass, it's in English.
Yeah.
But that's just background info, really.
Mm-hmm. The values in the questions themselves.
Exactly. The real value for us is how these questions sort of spotlight key knowledge points.
Right. Okay, let's unpack this then.
Yeah, let's use these questions to shine a light on, specific important concepts that this source reveals.
Sounds good. Think of each question, and maybe more importantly, its explanation as a sort of focused lens. It directs our attention to one particular function or mechanism that's pretty important to get within this whole Hitachi environment.
All right, let's dive straight in then. First concept, the source flags.
Yeah.
It asks about the main purpose of Hitachi Ops Center Protector.
Protector, yeah.
What's this tool really for, according to our source?
Okay, so the source is pretty direct on this one. It says Ops Center Protector's main role is, well, protecting data.
Okay, simple enough.
And it tells us how, by doing backup and replication tasks. The explanation really stresses that this is all about making sure data is available and, crucially, that you can recover it if, things go sideways.
Got it. So Ops Center Protector equals data protection. Backup, replication. Basic, but yeah, absolutely fundamental for storage.
Definitely.
Okay, now let's pivot a bit. Let's look at a specific system type that comes up. Global Active Device, or GAD.
Yep, GAD.
The source brings up a question about how GAD actually syncs data between different sites. What protocol does it name for this job?
Yeah, for GAD systems, the source points specifically to Hitachi Remote Copy Protocol, HRCP.
HRCP.
And it notes that HRCP is specifically designed for this job, for efficient data sync between sites that could be pretty far apart geographically. And importantly, it supports real-time replication.
Real-time.
Yeah.
So HRCP built just for that real-time, distributed syncing that GAD needs. Makes sense it would need its own specialized thing.
Exactly. You need something tailored for that.
Okay, now here's where, for me at least, it gets really interesting. The quorum disk in a GAD setup.
Ah, the quorum disk, yes.
Question 3 in the source asks what problem this disk is supposed to prevent. It sounds like a really critical piece, kind of lurking behind the scenes.
Oh, it absolutely is critical. And the source's explanation here is quite illuminating, actually. It tells us the quorum disk is there specifically to prevent split brain scenario.
So, right.
Which is, potentially a terrible situation. It can happen if, say, network problems break the link between the two GAD sites. Without some kind of tiebreaker, both sites might wrongly think they're the primary one. They could start accepting different data changes, and suddenly, bam, your data is inconsistent across the sites.
Oh, that's bad.
Yeah. So the quorum disk acts as that tiebreaker. It helps decide which site gets to stay active, avoiding that data divergence.
Preventing split brain. Wow. That's actually a fascinating detail about how these systems keep data integrity solid, even when the network hiccups.
It is.
It's not just about copying data, it's about coordinating who's actually in charge during a potential crisis.
Precisely. Coordination is key.
Okay, sticking with the Ops Center suite for another second, the source also brings up performance management. Question 4 asks about the specific Ops Center tool you'd use for analyzing system performance. Which one is it?
According to the source material we have, Ops Center Analyzer is the dedicated tool for that performance analysis piece.
Analyzer.
Yeah, its job is basically collecting and then analyzing performance data from the storage systems.
Yeah.
This helps admins figure out, how to optimize things, make it run better.
Right. So, Analyzer for performance, Protector for protection. Good to see those functions kind of clearly separated in the tool set.
Makes sense to specialize.
Yeah. Now, the next concept the source brings up is CCI. That's the command control interface. It asks about its main function, especially when you're managing GAD volumes. What does the source say CCI is mostly used for?
Okay, CCI. The source describes it as a command line tool.
Command line, right.
And its main function, particularly with GAD volumes, is running scripted batch commands for managing those volumes. The explanation really emphasizes that this is key for automation,
Automation, yeah.
and also for allowing really precise control over the volumes.
Command line and scripting that immediately makes you think, yeah, automation and getting that fine-grained control, super important in complex setups.
Absolutely essential sometimes.
Okay, let's look at a really fundamental difference in replication now. The source highlights this in question 6, synchronous versus asynchronous replication. What's the key distinction the source points out between those two?
The source really focuses on two things here: network bandwidth usage and the whole acknowledgement process.
Okay.
It clearly states that asynchronous replication typically uses less network bandwidth. And the reason is crucial. It does not wait for an acknowledgement like a confirmation from the target site before it finishes a write operation on the primary site.
Doesn't wait.
Got it. In contrast, the source notes that synchronous replication does wait for that acknowledgement. That's how it guarantees zero data loss.
Oh, okay.
But the trade-off is potentially higher latency and needing more bandwidth.
Ah, so the waiting is the key difference. Async doesn't wait, uses less bandwidth, maybe tiny risk of data loss in a specific failure moment. Sync does wait, guarantees zero data loss, but needs better network pipes.
That's the essence of it, yeah. The source's explanation makes that trade-off pretty clear.
Okay, moving to a practical, operational thing. Question 7 deals with expanding a GAD volume after it's already set up. What critical action does the source say you absolutely have to do after you expand it to keep the data consistent everywhere?
Yes, this is a really vital step, the source points out. You must perform a resynchronization after you expand a GAD volume.
Resync. Oh,
Yeah, the explanation tells us this resync process is needed to make sure that all the sites now have that newly expanded volume, and the data on it is consistent and up to date across the board. Keeps everything mirrored correctly.
Right. So expansion isn't just about making it bigger. You need that resync step to keep the mirrored data perfectly aligned. Good practical point from the source.
Very practical, yes. Easy to forget, maybe.
Network setup, obviously super important for distributed systems like GAD. Question 8 from the source asks about the recommended network setup if you want to optimize GAD replication speed. What does it suggest?
Well, no big surprise here, maybe, but to get the best performance, the best speed, and importantly, reliability for GAD replication, the source recommends setting up a dedicated high-bandwidth replication network between the sites.
Dedicated and high bandwidth.
Exactly. This setup is considered ideal because it helps minimize things like latency and packet loss, which are, the enemies of fast, reliable data transfer.
Makes sense. Dedicated high bandwidth network, that's the sort of the plumbing needed to make sure that real-time HRCP traffic we mentioned earlier can actually flow properly without getting choked up.
Precisely. It connects those ideas together nicely.
Yeah, it does. Okay, shifting back to management and automation for a sec, the source brings up the Hitachi Ops Center REST API.
Ah, the API.
How does using this API actually improve storage management workflows, according to the material?
The source points to integration as the main benefit here. It explains that the REST API enables integration with external automation and orchestration tools.
Right, hooking into other things.
Yeah, and this ability lets you create flexible and programmable storage management workflows, moving beyond just clicking buttons manually.
It's huge, right? Especially for modern automated data centers, being able to weave storage management into those bigger IT automation scripts using APIs.
Absolutely critical these days.
All right, final question we're going to pull from this source material. This one asks, what is not a valid use case for Hitachi GAD? So what it's not typically used for.
Okay, yeah, this particular question in the source, its presentation is a little interesting.
Oh, how so?
Well, the source states that the correct answer option is A, which is storage tiering across different media types.
Okay, so GAD isn't for storage tiering. Makes sense.
Right. However, the explanation provided in the source actually focuses on a different answer option, option D. The explanation says that volume migration between storage arrays is not a typical function of GAD.
Huh. So the answer says A, but the explanation talks about D.
Kind of, yeah. The explanation clarifies that GAD's focus is more on use cases like data replication, disaster recovery, and that active data usage we talked about. It explicitly says volume migration isn't a typical GAD function within that explanation text.
Fascinating. Okay, so just to be clear for everyone listening, we're reporting exactly what the source presents here. It gives storage tiering as the answer for what GAD is not typically used for.
Correct, answer A.
But then its own explanation focuses on volume migration also not being a typical function, while confirming it is used for replication, DR, and active access.
Precisely. The source presents answer A, storage tiering, as the not a use case answer, and the provided explanation discusses why volume migration isn't typical, while listing replication, disaster recovery, and active usage as the things GAD does focus on. It's a slight mismatch between the stated answer and the focus of the explanation text.
Interesting little inconsistency there in the source material itself.
To how we automate complex storage tasks through essentially a programming interface.
Mm.
How does all this underlying complexity in the storage systems we use, how does that influence how we should think about the reliability, the accessibility of all the digital information we just rely on constantly every single day?
Hmm. That's a good question. What else might be happening, behind the scenes in the infrastructure that powers our digital lives? Stuff we never even consider. Something to ponder.